Hello and welcome to this short lesson on the nth term of a linear sequence, also known as an arithmetic sequence. Okay, so just as a quick overview, the nth term allows us to represent a linear sequence in a nice neat equation, and it enables us to find any term of a linear sequence without having to write down every term. Okay, so just as a quick recap, so we're all on the same page with a basic example. This is an example of a basic linear sequence. And what I mean by sequence is just a list of numbers. And what I mean by linear is that this sequence is just changing by a constant amount each time. So here we see to get from 3 to 6, we just add 3. 6 to 9, we add 3. 9 to 12, we add 3. So we're changing by a constant amount each time, and that's what we mean by linear. Okay, so the first number in the sequence is just the first term. The second number in the sequence is the second term. The fourth number in the sequence is the fourth term. So that's what we mean when we talk about the terms. And finally, this ... on the end just tells us that the sequence continues forever. And obviously, we can't write that all down. Okay, so the first thing I'm going to cover is the nth term here is just 3n. And how I can tell that the nth term here is 3n is that we can use this nth term 3n to get back to our original sequence. So, to find our first term or our 1th term, we would just substitute in n equals 1, and we get 3. If we want our second term, we just substitute in n equals 2, and we get 6. If you want our third term, we just substitute n equals 3, and we get 9. So you get the idea. So we can get our original sequence back using the nth term. As stated above, our first term is just 3, our second term is just 6. But what if we wanted to find the 100th term? Well, we could write down 100 different numbers of this sequence, but that would take far too long. So what we can just do is use the nth term which I provided here. So our 100th term, using our nth term, we would just substitute in n equals 100, which gives us 3 times 100, which equals 300. So we just calculated our nth term in seconds without having to write down 100 different terms, which is why this technique is so powerful. Okay, so now I'm going to go through the method of actually finding the nth term. It's a 4-part method, but this is just a framework. Once you do a bit of practice, you'll be able to do it in your head without using these different steps. Okay, so here we have an example of a linear sequence, 2, 6, 10, so on. Our first step is just to find the constant difference. Okay, so how do we get from 2 to 6, 6 to 10, 10 to 14? Well, each time we're just adding 4. So our constant difference here for step 1 is just plus 4. Okay, so step 2, we need to create a sequence using that difference. So what I mean by that, our constant difference is plus 4, so we just write 4n, which is represented by 4 times 1 for our first term, which is 4, 4 times 2 for our second term, which is 8, 4 times 3 for our third term, which is 12, and it's just a 4 times table. So that is simple enough. Step 3. How do we get from our new sequence back to our original sequence? So how do we get from 4 to 2? How do we get from 8 to 6? How do we get from 12 to 10? What do we need to do to the sequence to get back to that original sequence? Well, clearly, all we need to do in this case is just -2. So, step 4. We just need to combine this information. We know if we have 4n here, and we take 2 from this sequence, that's going to represent our original sequence. We're going to get back to our original sequence. So our nth term, simply put, is just 4n take 2. And that's it. Each of these steps is very easy, but the hard part is just remembering the method. So our nth term here is just 4n take 2. Our first term is just 2. Our second term is 6. We can read this from the question, or we can use our nth term. So to find our first term, we would substitute in n equals 1. So 4 times 1, and then take 2, which is just equal to 2. To find our second term, we would do 4 times 2 take 2, substituting in n for 2, and then that would just equal 6. Okay, so to find our 100th term, we don't want to write down 100 different numbers of the sequence, so we can just substitute in n for 100. So we have our nth term of 4n take 2, substituting n is 100, we get 4 times 100 take 2, which is just equal to 398. So our 100th term is 398. And we've just calculated that in seconds without having to write down 100 terms. Okay, so here's a second example, and we're just going to be using these same steps as our framework. Okay, so step 1, find the constant difference of this sequence. Well, we're just going to be adding 6 each time to get to our next number. Oops, no idea what happened there. So for step 1, we have plus 6. Step 2, create a sequence with this difference. So we just do 6n as our difference is 6. And this is just 6, 12, 18, 24. And we can calculate this sequence by substituting in n equals 1, n equals 2, n equals 3, so on and so forth. Or we can just recognise that 6n is just going to be the 6 times table. So, how do we get from our new sequence back to our original sequence? What do we need to add or subtract from this sequence here to get back to this sequence? So if we just look at it at a turn-by-turn basis again, how do we get from 6 to 51, 12 to 57, 18 to 63? And the answer is we just need to add 45. So step 4, combine this information. We know if we have the sequence 6n and we add 45 to it, we're going to get back to our original sequence. So our nth term is just 6n plus 45. And I'll just write that again down here. Okay, so to find our 100th term, we don't want to write down 100 different numbers. So again, we just use our nth term. So we substitute in n for 100, and we get 6 times 100 plus 45 equals 645 is our 100th term of this sequence. Okay, so one final example, which can look intimidating and a bit more tricky because it does involve negative numbers, but it is the exact same process. So, step 1. Find the constant difference. You can see here that every single time we're just going to be subtracting 7. So, our step 1 answer is just -7 for our constant difference of the sequence. Step 2. Create a sequence with this difference. So, we'll just have -7n, which is just the -7 times table. So -7, -14, -21, so on. Step 3. Again, how do we get from our new sequence back to our original sequence? So if we do this term by term, how do we go from -7 to -3, -14 to -10, -21 to -17? Well, all we need to do is add 4. So, step 4, if we combine this information, we know if we have the sequence -7n and we add 4 to that sequence, we're going to get back to our original sequence. So our final answer is -7n plus 4 is our nth term. Again, to find our 100th term, all we need to do is substitute in n equals 100, and we get our 100th term as -696. Okay, so a couple more questions you could be asked surrounding this nth term, which are a bit trickier, are as follows. You could be asked something along the lines of, is -255 a term in this sequence? Well, if -255 was a term in this sequence, we would be able to write it down using our nth term. So we would be able to write -7n plus 4 equals -255, where n here is just a positive whole number. And the reason it has to be a positive whole number is because n represents our terms, and our terms are the first term, the second term, the third term, and these are just positive whole numbers. So if there exists an n for which this equation is true, then -255 is a term in our sequence. So all we need to do is solve for n, or find n, and ask ourselves, is that a positive whole number? So we just need to rearrange this equation. So if we just take 4 from each side of our equation, we will have -7n equals -259. Divide each side by -7, the negative cancels out, and we'll have 259 over 7, which, using a calculator or in your head, we can just see it's 37. So, to put it clearly, -7 times 37 plus 4 equals -255. So, as this n is a positive whole number, we can say yes, -255 is a term in this sequence. In fact, it is the 37th term in the sequence. Okay, so just one more example along these lines. Is -496 a term in this sequence? Well, if it is, we would be able to write -7n plus 4 equals -496. So let's rearrange for n and see if it's a positive whole number. So again, let's just start off. Take 4 from both sides. We have -7n equals -500. Now divide both sides by -7. The negatives will cancel out, and we'll have n equals 500 divided by 7, which, using a calculator or just working it out, we can see that this is not a whole number. This does not simplify into a whole number. 500 is not divisible by 7. So, -496 is not a term of our sequence, as it cannot be represented by our nth term that we calculated. Okay, so what have we learned? We've learned a method to find the nth term, and we've found out why the nth term is so valuable. We can use the nth term to find the 1/1000th term in seconds without having to write that down and calculate all of those numbers. Also, given a number, for example, -255, we can use the nth term and rearrange to say if that number is in our sequence, which is quite powerful. And just for extra clarity, I've added some extra questions and answers in the description, which you can look at and try out yourselves. And if you have any questions or problems, just put it in the comments or drop me an email and I'll be sure to get back to you. Thank you for listening.